Hi everyone, and welcome to another example of the elasticity of demand. All right, so here they just give us the function. So instead of a word problem, so we don't really need a word problem on these problems anyway, because they'll just pretty much give us the function regardless. So we've got this function. So it's let q equal d of p equal the square root of 200 minus p. Find the following, the elasticity. All right, so the elasticity again is this function where we have negative x times the demand function's derivative over the demand function. But they are using a different letter in this problem. They're using p. Okay, so we should do that too. Okay, so let's change it. So we'll say E of p is negative p times the derivative of the demand function over the demand function, just with different letters. Okay, so we're still finding the elasticity on this, just with different letters. Now, like before, I'm going to put this over here. So we have d of p equals the square root of 200 minus p. But we need a derivative, so we should probably change that to be the half power, so 200 minus p to the half power. And that makes it easier to do the derivative. So we have d prime of p. Now, this is a chain rule problem. The 1/2 comes to the front. So we have 1/2 and then parentheses 200 minus p. Minus 1 from the power would be negative 1/2. And then times by the derivative of the inside the parentheses here. Well, the derivative of that would be negative 1. Okay, so we can see this would simplify. So d prime of p would be negative 1/2 parentheses 200 minus p to the negative 1/2. Like that. Okay, and if we want to, we can also change that to be back as a square root. So we would have negative 1 in the numerator and then 2 square root of 200 minus p in the denominator. So remember the negative half power, the negative would move it down to a denominator, and then the half power is the same as the square root. Okay, so this might be a little better in our scenario. Okay, and let me color it in blue actually to show our substitution. Okay, so there's our derivative work, but that's going right here. Okay, so now let's plug all that in. So we have E of P is equal to the big fraction, negative P, and then times, let's keep it in blue, negative 1 over 2 square root of 200 minus P, and then all divided by d of p. We also already had that. That's just the function they gave us from the start. There it is, square root of 200 minus p. Okay, and then now we need to simplify this. Well, usually the way that I simplify a complex fraction, so here we do have a fraction in a fraction. I just look at the denominator. So right here, this denominator, the small denominator, and that's the only one that has a fraction in it in this big scenario of the big fraction. So that's what I should multiply the top and bottom by of this big fraction to simplify. Okay, and what that does, so let's simplify it. I think I've got enough space. Okay, so big fraction bar. All right, so let's highlight. So a lot's going on, but in the whole numerator, the numerator is all multiplication. This would have divided with that. Okay, so that's why we multiply by that denominator on both top and bottom to get rid of this complex fraction. So the yellow highlighted stuff cancels out, it's gone. And then we would have had negative p times negative 1 here. So this negative 1 and negative p would be just positive p. So in the numerator, we have positive p. And then in the denominator, this 2, I'm just going to put right here. And then notice these two, let's do one other highlighter. Let's do it in green. These two are the same thing times themselves under a square root. Remember, if you have a square root times a square root and everything in it are the same, so like square root of x and square root of x, that would be just x. Okay, and you could try it with regular numbers, like square root of 4 times the square root of 4 is just 4, because, well, that would have been 2 times 2, which is still 4. Okay, so these two in the green highlight are exactly the same. When they multiply with each other, we're left with just the expression that was underneath that square root, so no more square root, 200 minus p down there. Okay, and then that might be it. They might distribute the 2. So I'm going to put it right here. So that might be fine. But for a final answer, let's say it's p over 400 minus 2p. Okay, so I just distributed the 2 in the denominator. Okay, so there's our elasticity function, elasticity of demand. So they often abbreviate it the just elasticity. Okay, so now that we've got it, let's use it. So they say the elasticity at p equals 40 is what we want to find, and then state whether the demand is elastic or inelastic. So find the following. Let's find this. Okay, so that is just plugging in 40. So we have E of 40 equals 40 over 400 minus 2 times 40. And then we'll simplify this as far as we can. Now, again, a calculator we could probably just use, but let's show those steps. So we would have 400 minus 80. And then let's keep it going. 40 over 320. Now, they both end in 0, so those zeros cancel. And then 4 over 32, I think 8, or 4, they're each divisible by 4. Divide by 4, divide by 4, and I think it's 8, right? So 8, 16, 24, 32. Yeah, so we have E of 40 is 1/8, and then let's get the decimal of it. They probably want that anyway, which would be 0.125, and we could have plugged that into the calculator to get the decimal. Again, we could have probably done it from the start, just use big parentheses around the whole denominator. Okay, so there's our elasticity when P is 40. And it could be dollars or cents. They're not saying because it's not a pure word problem. So we'll just leave it as 0.125. Okay, and then state whether the demand is elastic or inelastic. All right, so we have these 3 inequalities, and we want to know which one is which. So each of the, and the last one's an equation. So this inequality is when it's inelastic. When E of x is greater than 1, that's elastic. And then when it is 1, we call that unit elasticity. Okay, so unit in math usually means something is 1, and that is this case. Okay, so they're saying, well, which one is it? Well, this is how they're defined. Okay, so if you had the last video, it was these ones. So that's how they define this function from economics. Okay, so we've got that to help us. And so then we can just say, well, it's this first case, so it is inelastic. Okay, and then they might also say, well, what does that inelastic mean? Let's also state it from without scrolling. We would just say a small increase in price will result in an increase in total revenue. Okay, so that's what it also means in case they ask for that. Okay, so all that inelastic instantly means this statement. So if this is in dollars, and it says, let's take that. It says it's assume $1 in the next step. So let's just put a dollar symbol on there. So, I mean, currently that's 13 cents about. Okay, so it's saying, well, if they raise the price, say make it 20 cents, then which should mean that we have an increase in total revenue for whatever this situation really is. Okay, so that's how we can break that down. All right, so let's see this next one. So number 3, it asks to find the values of P for which total revenue is a maximum. Okay, so that's the same as when E of x is equal to 1. All right, that's all the main thing, or the rephrasing of it means. So we'll take our equation that we found from step 1. Let's rewrite it. Oh, and I wrote x, but again, all of these I guess should really be p. Okay, so I'm going to keep those as x, because x is kind of more common. Okay, but I changed this one to p so that it can match our actual equation that we found, which was boxed in number 1. So p over 400 minus 2p like that. Okay, and they want us to find the values for when it does equal 1. So it's saying change this and just make it into 1. And then now solve this equation. So to solve this equation, usually it's just a quick cross multiplication because this 1 is instantly over 1. So we can take the 400 minus 2p and multiply across, and then that 1 and multiply across. So we would have 400 minus 2p is equal to p. And then now we're solving for p here. So we should add the 2p over. So we've got 400 is equal to 3p. And then we'll divide by 3. Okay, so divide each side by 3, divide by 3. And we have, well, this 400 thirds is p, but let's change it. Let me see how much space I got. Yeah, let me put that arrow up there like I was doing. Let me even write it a little higher. Okay, so that will just plug into a calculator. Now I've got my calculator to the side. You can trust me on this. So 400 divided by 3 is 133. So our P is $133, and then rounded to the nearest cent is 33 cents. So it's a run-on decimal. Okay, so that's the price that would make for total revenue, or for total maximum revenue, that price right there. So that's it. Okay, so this is a made-up problem, so we don't know what it is. So obviously this 12.5 or 0.125 cents is, or dollars, I mean, sorry, so 12.5 cents for that step 2 is definitely inelastic. So that's making sense. So at this point, it'd really be a big price increase is needed. Okay, so $100 extra. Okay, anyway, that's it though. Okay, so that's how we do elasticity. So again, just make sure you got your equation down. Let's box that. And then really make sure to know the 3 cases afterwards, what happens with it. Okay, so we're just looking at those values after to know whether or not we have needing an increase in revenue, decrease, or if it's maximum. Okay, so thanks for watching. If you do have any questions, please let me know. Otherwise, I'll see you next time.